Hello and welcome to my tutorial video on how to connect your OEM Subaru microphone to an aftermarket head unit. If you followed my series on how to install an aftermarket head unit in Subaru Outback or Legacy 2015, 2016 and 17 models, the links to which I will add to the description, you may also have a question. Is it possible to connect the stock microphone installed in your Subaru vehicle to an aftermarket head unit? The reason for this question is simple. The external microphone supplied with the aftermarket head unit may not provide adequate voice over Bluetooth quality. In fact, the quality of the microphone supplied with my 8Auto S8 Ultra Android unit was so poor that people on the other end of the phone, most often than not, could not clearly hear what I was saying when the car was in motion. For me, it was a huge downside, since phone conversations while driving is an essential part of my job. I figured that I was not alone with this problem. There are some discussions in the internet, such as XDA developers forums dedicated to FYT-based Android radios, about whether it is possible to modify the firmware of the aftermarket head units to increase microphone sensitivity. None of these tricks worked for me, unfortunately. It seemed replacing the external microphone was the only option. There are hundreds of inexpensive external microphones being sold on Amazon, but why buy another one with an unknown quality when we already have an excellent microphone installed in our Subarus? It never failed me before, and it should be fairly easy to connect, shouldn't it? That was a huge question, and I spent quite a bit of time researching internet trying to find the answer. Automotive manufacturers don't make it easy for people and don't provide clear documentation about parameters of their stock microphones. Many people like me are asking the same question on various automotive forums, and the answer does not seem to be clear. Let's look at the service manual for my Legacy Outback 2016 and at the stock 6.2-inch head unit diagram. It features a 28-pin connector. The same connector, which is developed by Toyota, is used in many Japanese brand vehicles, such as Toyota itself, Subaru, and Nissan. Not only the connector is shared across various makes, but it seems even the pinouts are very similar, according to my research. Here's the table defining the pinout of this 28-pin connector. Let's look specifically at the pins dedicated to the microphone. There are 5 pins for the microphone: mic plus B, mic plus, mic DET, shield ground mic, and mic minus. Just too many wires for a simple microphone. Here are these pins shown in orange on the connector itself. For the reference, I also labeled the pins that are used by the crux interface, which connects the aftermarket unit, with green color. Let's have a detailed look at these pins. Mic plus lead on pin 5 supplies main microphone signal to the head unit. The mic plus B lead on pin 4 supplies power to the microphone circuit. The OEM microphone is pre-amplified and therefore needs to be powered. While there is no mentioning of the voltage, many internet discussions suggest that plus 5 volts should be used. Mic DET or detect lead on pin 6 is interesting, and there are some discussions whether this lead is used by the stock radio to determine whether the microphone is connected. Some suggest that it should be connected to the ground, but I figured I can simply ignore it whatsoever. Finding which of the shield ground mic or mic minus leads to use was a bit trickier. Ideally, mic minus should be a dedicated lead for returning the microphone signal, while isolated ground should be used as a return for the power. Luckily, The service manual did provide an electric circuit diagram for these two leads and how they are used. I will discuss the diagram in a minute. It turned out that only one of these leads, mic minus, was actually used as both mic signal and power return. The other one, from what I understand, is just a shield that is connected to a common ground of the chassis. It is possible to connect them both to attempt to reduce the induced noise of the microphone. But I preferred leaving the shield ground mic lead alone, since I'm not sure whether it is a good idea to combine the ground of the chassis with the ground of the plus 5 volt power supply. That leaves us with three leads: mic plus B, mic plus, and mic minus / ground. Let's now look again at the diagram. As I mentioned before, the shield lead is connected to pin 18 and it's not going to be used. The other three leads, connected to pins 4, 5 and 19, are the leads for mic power, mic plus signal, and combined mic minus / ground. We now know the leads that will be used to connect our stock microphone. But here's an issue. The external microphone of an aftermarket head unit uses a non-amplified condenser microphone that generates a signal in a millivolt range. The voltage signal generated by a pre-amplified stock microphone may be way too high for the aftermarket radio, and this signal needs to be attenuated or reduced in power. That is, of course, unless we decouple the actual microphone from the amplifier circuit and solder it directly to the leads, which wasn't a way for me. To attenuate the amplified signal, a voltage divider is required. Luckily, for an unbalanced microphone such as this one, a voltage divider is a very simple electronic device that can easily be built by using just two resistors. As for the plus 5 volts, the easiest way to obtain it is to use one of the USB ports of an aftermarket head unit. Here's a simple circuit diagram which gives an idea of a simple DIY adapter or attenuator that we will need to build. Pin 4 is powered by the VCC pin of a USB port. Pin 19 is connected to the ground of the USB and serves as a return line for the mic plus signal, which is attenuated by two resistors, R1 and R2. The attenuated microphone signal is supplied to the 3.5mm audio jack, which will be plugged into our aftermarket head unit. A small decoupling capacitor of about 10 microfarads can also be added in line with the mic plus signal line, but my tests showed that it didn't provide any additional improvement to the sound quality. The 3.5mm audio jack can be of any kind, TRS, TRS or TS. If you use a jack with one or two rings, all these rings should be connected with the sleeve and with the ground. Choosing the values of R1 and R2 resistors may be a bit tricky, since we don't know the impedance of the stock microphone and the impedance of the head unit. Of course, one can go too technical and measure the impedances with an oscilloscope, but since I don't have an oscilloscope, I decided to go an easy way. To find the desired R1 and R2, I first assembled this circuit using a 10 kilo ohm potentiometer as a voltage divider. After the circuit was plugged in, I used a voice recording Android app to record my voice through the stock microphone and adjusted the pot until the most acceptable sound recording quality was achieved. I then measured the R1 and R2 of the potentiometer with a multimeter. By acceptable, I mean a decent noise to voice clarity ratio with no signal cutoffs. The lower R1 and the higher R2, the louder the signal will be, but it may saturate the head unit microphone amplifier, and we may start experiencing voice distortions and cutoffs. On the other hand, if the R1 is too large and R2 is too small, the final microphone signal will be too low to hear at all. By trial and error, I found that values around 7 to 8 kiloohms for R1 and 2 to 3 kiloohms for R2 gave me a good balance between my voice being clear and without distortions, and with acceptable noise level. The final values for R1 and R2 were 6.8 kiloohms and 2 kiloohms, simply because these were the resistors that I already had at home at my disposal. I then soldered all the leads and the resistors on a small piece of a prototype board. These are the components you will need to build your DIY stock microphone adapter. A 28-pin Toyota extension harness, a Type A USB male plug, a 3.5mm audio jack with a cable, a 6.8 kiloohm resistor, a 2 kiloohm resistor, a small piece of a prototype board, and a small box, preferably made of metal, to feed the board with the attenuator. I will add some links to the description of this video where I purchased most of these components. Unfortunately, I cannot guarantee that these links will work in the future. Here is the final view of my DIY adapter, which includes the extension harness for the 28-pin connector, a small box with an attenuator, Type A USB plug, and a 3.5mm audio jack. I will skip the installation procedure as it should be self-explanatory. Plug in the USB plug to a USB port of the Aftermarket Headunit. For instance, my 8Auto S8 Ultra provided 4 ports on the back, one of which was used to power the microphone. Then plug in the 3.5mm audio jack to the microphone port of the head unit. Plug in one end of the extension harness to the factory 28-pin connector, and finally plug in the other end of the extension harness to the 28-pin connector of the crux interface. This is it, folks. For those of you who are wondering what was the difference between the external microphone of my 8Auto S8 Ultra head unit and the Subaru stock microphone connected with the head unit with this DIY adapter, here are a couple of voice recordings. These recordings were edited to exclude some non-essential parts, but otherwise kept unprocessed for easy comparison. Feel free to leave your comments below, and thanks for watching. I am testing the external microphone for 8Auto S8 Ultra unit, and I will be driving around and I will be speaking to the microphone as if I were talking on the cell phone. I'm driving around the neighborhood, approaching 40 kilometers an hour, speaking on the phone, speaking normally as if I were talking on the cell phone to somebody else on the other side. And I will be testing later on what was the quality of this recording. So let's go a bit faster, maybe 50 kilometers an hour. That's 50 here. So going 50, or actually lower it now. Test number 5, it's October the 22nd, 8:27 p.m. and it looks like this particular setting works much better than it was before. I've changed the resistance values, and hopefully my Subaru OEM microphone will be working much better. So I started driving, and just making a turn here, speaking normally as if I were talking to somebody else on the cell phone. I'm actually going just at the 40 kilometers an hour, and I'm going to make a turn to the road which let me drive 50, let's go see how it performs at 50 kilometers an hour. And my fan is working. Let's make it louder, just to make sure that we are picking up as much noise as possible. So obviously on the highway, when the speed is much higher, it's going to be way noisier. And so it was over 50 kilometers an hour.